Okay, so the lesson that we're going to do today is logarithms. So the first rule in logarithms is the product rule. So the product rule means that log x plus y is equal to log xy. So the plus means that you're going to multiply the two numbers that are right there. The next one is the quotient rule, and the quotient rule says that log x minus log y is equal to log x over y. So when you're subtracting, you're going to go ahead and divide the two numbers that are there. As long as they have the same basis, and this is for all of the rules, as long as they have the same basis, then you can apply these methods to it. The next one is the equality rule. It means it's saying that log with the base of bx is going to, if it's equal to log with the base of by, then x and y are going to be equal to each other. Because this base is the same as this base, you can automatically assume that they're the same. So that means this x and this y are going to be the same to each other. The next one is the power rule. So the power rule is saying that when you have an exponent to the number, that means that it's also a coefficient. So you can go ahead and rewrite that to just condense it. You're going to say log base bx to the power of y, it's equal to saying y, which is from the exponent, the coefficient y log base b is equal to x. Sorry, is x. The next rule is order. So order is saying there's a specific way to remember order. Order is by saying, there's always something that I say is called base, exponent, answer. So first you're going to put, in order to rewrite this, you can say the base, you're going to take the base and put it as a coefficient. So base, your exponent is going to be your answer from this problem, and you're going to put the coefficient, which is, the exponent, which is b to the power of y, and x, your number, is going to be your answer. So this is how you're going to rewrite it, and this is how you solve it. So back to this, we're going to go to the different exponential rules. So for the exponents, there are different rules, but they're kind of similar to the ones above. It's saying that x to the power of n times x to the power of m. In order to condense it, you're going to add the two exponents together. The next one is saying that x to the power of 0 will always be 1. No matter what number x is, it's always going to be 1 as long as it's the power of 0. The next one is saying that x to the power of negative y is equal to 1 over xy. So whenever you have a negative exponent, you're going to have to do the reciprocal of it and make it into a fraction in order to make it positive. And that's how you solve for that. The next one is x to the power of n divided by x to the power of n, which is equal to x n minus m. So when it's division problem, you're going to subtract them. And the last one is x to the power of n. When it's in parentheses and it's multiplied by another exponent, then you're going to just go ahead and multiply the exponents together. Okay, so now we're going to start with the examples. So the first example is log x minus 3 is equal to negative 2. So according to the rules, you know that you're going to go ahead and automatically, what should come to your head is the different rules. The first rule that came up to my head was the base. You know base is 10. You're going to do base, exponent, answer. So you're going to do the base of 10 to the power of negative 2 is equal to x minus 3. Now you're going to try to solve for x. So you know x to the negative 2, one of the exponent rules was that when you have a negative on top, when you have a negative as an exponent, you have to do it into a fraction. So you're going to do 1 over 10 squared is equal to x minus 3. You know 1 over 10 squared is 100, so you have 1 over 100 is equal to x minus 3. In order to get x isolated, you're going to add 3 on both sides. And you're going to get 100 plus 3 is equal to x. You can go ahead and simplify that and... Okay, so you know 1 over 100 plus 3 is equal to 3.01 is equal to x. And that's your answer for that first one. Okay, now for the second one, it's a little complicated because we have ln rather than log. So ln, you know the base of ln is e automatically. Now you know because there's an addition, you're going to have to multiply the two. So you have ln base e. You have x plus 1, x minus 1. In order to reduce that, you're going to FOIL it. So you're going to have ln e x squared. X times negative 1 is negative x. 1 times x is positive x. And then 1 times negative 1 is negative 1 is equal to 0. Don't forget that 0. Now you can simplify this. These cancel out, so you're left with ln, the base of e, is equal to x squared minus 1 equals 0. So now you're going to do it the same thing that you did here. You have base e, of 0 is equal to x squared minus 1. You know, when you have something, any number to the power of 0 is always going to be 1. So e to the power of 0 is 1 is equal to x squared minus 1. You want to solve for x, so you're going to add 1 on both sides. And you have 2 is equal to x squared. Square root of both sides to get rid of that square. And you have the square root of 2 is equal to x. When you simplify that, if you want, you can use the calculator. You get x is equal to 1.414. And those two are your answers.